Hi everyone, welcome to this series of videos on the basic inventory models. In the last video, we looked at the economic order quantity model. Let me quickly go over it once again so that we have a decent idea of where we're starting. So in the economic order quantity model, we made a few assumptions and some important ones, right? So in the economic order quantity model, we assume that demand is known and is constant, lead time is known and is consistent. The receipt of inventory is instantaneous and complete, and this is one of the assumptions that we'll be relaxing with the production order quantity model. Quantity discounts are not possible, and only variable setup or only variable costs are set up and holding costs, right? And stockouts are completely avoided, right? So in this model, what happened was you would place an order. When your inventory was zero, the order would arrive instantaneously. So your inventory became capital Q, which is the amount of order quantity, right? Then you would slowly use up the inventory, and then you would plan it in such a way that, so if you had a lead time and everything, so lead time is the time between placing an order and receiving an order, you would plan it in such a way that you place the order and the order gets received after, let's say after a little while, it is received in, you place the order in such a way that the order arrives just as your inventory becomes zero. And the reason to do this sort of planning is so that you don't hold too much inventory. If you hold too much inventory, your holding costs become higher. So you plan it in such a way that once you place an order, the order arrives as soon as your inventory becomes zero. Right. So here, assuming that your whole inventory arrives at the same time, even if the condition of instantaneous is relaxed, you are still assuming that the whole inventory comes in at the same time. But in the production order quantity model, which is an extension of this model, we are assuming that we are not buying our inventory from a third-party supplier, but we are making the inventory that we are selling by ourselves. We are manufacturing the goods and we are selling the goods ourselves, right? So let's see what that situation is like. Oh wait, I think I went back too far. Right. Okay. So this is used when inventory builds up over a period of time after an order is being placed or after you start manufacturing. Used when units are produced and sold simultaneously, right? So the way the inventory level works is, let's say that you decide that Q is how many units you're going to produce, right? So, but all Q items will not be produced instantaneously. You'll produce them slowly. So what you notice is that your inventory slowly builds up for a while. And also remember that we have to make the assumption that the demand that we face is less than our production capability. If we cannot keep up with our production, if our production capability cannot keep up with demand, then anything we produce is immediately sold. So you're not holding any inventory at all, in which case you're just continuously producing throughout the year, and that is not the situation that we are looking at. In this situation, you are capable of producing a lot more than you can sell, or at a higher rate than you can sell. So what you do is you manufacture for a certain period of time, build up an inventory of goods, then you stop. And then you wait for your inventory to go down to zero, then you manufacture again, then you stop, and then your inventory goes down to zero, and so on. So this sort of seasonal manufacturing is a very common thing that is seen in many manufacturing settings, because running factories takes a lot of money. So if you can run them for, say, 3 months, then take a 2-month break, and then come back for 3 months, and take a 2-month break, or do it in 3-month chunks, it is helpful. Or you move from producing one type of item to another type of item, right? So the inventory of the first type of item that you produce builds up to a certain amount, then you stop, and then you switch over to manufacturing something else. In the meantime, the inventory of the first item goes to zero. As soon as it's coming close to zero, you switch over from the second item to the first item, and then you keep switching this way. This way, your factory is running throughout the year, your employees are employed throughout the year, but then you are manufacturing different items in different chunks. And that's the example that we are looking at here, right? So this is the part of the inventory cycle during which you are doing production and usage. Both production and usage takes place at the same time. And your inventory builds up to a certain amount. And after the inventory builds up to a certain amount, you stop your production of this particular item, right? And then this is the maximum inventory that you reach. And then what you do is you start slowly using up the remaining inventory over a period of time. So you'll notice that this slope is steeper than this slope. The reason for that is you're assuming that your production rate is higher than your demand rate. And the slope of this line here that you see here, this slope here, the slope here is the difference between your production rate and the demand rate. Because you're assuming that production rate is higher than demand rate, this difference is positive, but that's why the slope is steeper. Slope is not as steep as this slope here. This is much steeper because this is just the demand rate, right? You're just reducing demand at a demand rate, so it's steeper, right? And this is what you see. Okay. And the same cycle continues, right? So how is this model different from the economic order quantity model? So you can think of this as a slight extension of the economic order quantity model, but a lot of things that you looked at with the economic order quantity model also apply here. So we'll assume that Q is the number of units, we'll say per order, or we'll say per production cycle. Both things essentially mean the same. H is still the holding cost per unit per year. We'll say that P is the daily production rate. So this tells you how many units you can produce in a day, and D is the daily usage rate or demand rate. So how many units are on demand, right? So production rate and demand rate. So this is daily numbers. Now, they don't have to be daily numbers. They can be, say, weekly numbers, monthly numbers, or yearly numbers. The only important thing is that both of these should have the same units. If it's weekly for both, it's weekly. If it's daily for both, it's daily. Or if it's monthly, but they have to have the same units. But in general, we will assume that when you're looking at the lowercase numbers here, they are given in days. Uppercase numbers are in years, and uppercase letters are all referred to things that are based upon yearly things, and lowercase is for daily things, right? So T is the length of the production run. So that's how long you're producing. And so the maximum inventory level is the total produced during the production run minus the total used during the production run. So you produce P times T units. So P is the number of units you produce per day times T in days minus D times T. So this is the maximum inventory that is reached, right? So Q is the total inventory that you reach. So the production cycle T is Q divided by P, right? So if I plug that into the maximum inventory level here, so the maximum inventory level will be Q times 1 minus D over P. So this is the maximum inventory level. So in the economic order quantity model, the maximum inventory level that you reach is Q, because you place an order, the order arrives after a lead time. It might arrive after a lead time, but the whole order arrives at once. So your inventory becomes capital Q, right? But in the production order quantity model, you are using up some of the inventory as you're making it. So the maximum inventory that you reach is less than that. And how much less than that? That is decided by this ratio. How much slower is the demand rate than the production rate? So you take that ratio, you subtract that from 1, and then you have your maximum inventory level, right? So that's essentially what you have there. So that's maximum inventory level, and this is the major change between the economic order quantity model and the production order quantity model. So the maximum inventory level is this. So if this is the maximum inventory level, the average inventory level will be half of this, right? And so when you're calculating holding costs, you're going to calculate holding costs using this expression rather than just capital Q, like we did with the economic order quantity model, right? So the average inventory level will be half of maximum inventory level, and that's what you have. Q over 2 times 1 minus D over P. Okay. So the annual holding cost will be the average inventory level times the holding cost per unit per year. So Q over 2 times 1 minus D over P times H. So with the economic order quantity model, we did not have this expression 1 minus D over P as part of the formula. That is the major difference, like I said, between the whole economic order quantity model and the production order quantity model. All right. Okay, so the setup cost, which we called ordering cost, it will be called setup cost here because you're setting up the machine to make production. It's the same. So D over Q is the number of times you have to set up in a year, because Q is the production, how much you produce each time you produce. D over Q is how many times you'll have to set up in a year times the cost of setup. And that's the expected that's the setup cost. This is the holding cost. Again, remember that to find the optimal order quantity, you set these two equal to each other and you solve for it, and you'll notice that this is the formula for the optimal production order quantity, right? Now, again, If you compare this formula with the EOQ formula, the EOQ formula is 2 times D times S over H under square root. The only difference is that with holding costs, now you have this extra expression because you're not holding as much inventory. You're holding less because you're producing and using in the initial part of the cycle by yourself, right? And that's the main difference. So this is how much you should produce for each production run, right? So that's the production order quantity model, right? So let's look at a couple of examples, right? So let's assume that demand is 1,000 units. Holding cost is, setup cost is $10 and holding cost is 50 cents. Let's say that we have the capability of producing 8 units per day and our demand is 4 units per day, right? So this 4 units per day can calculate with the fact that annual demand is 1,000, number of working days in a year is approximately 250. So 1,000 divided by 250 gives you 4 units per day. So it's the same calculation we did before with the economic order quantity model, right? Okay, so with that we can calculate the optimal production order quantity. That will be square root of 2ds over h times 1 minus d over p. So if you plug in the formula, you'll notice that it is, this should be actually outside. So it's square root of 80,000 and square root of 80,000 will be 282.8 or 283. So you cannot have 282.8 because, well, you're trying to produce a whole number, right? So your production order quantity will be 283 wheels. So each time you do production, you will produce 283 wheels. Now this also might not be true because sometimes in some production cases, you might not be able to produce in, let's say, less than chunks of 10 or less than chunks of 25 in some cases, based upon the way your production is done. So you will round this up to the closest number. So let's say you can only do it in chunks of 10, then you will round this to say either 280 or 290, depending upon which way you want to go. 280 is closer. You would likely round this down to 280. Or if you're doing chunks of 25, you would actually round this down to 275. Or maybe 300, depending upon how you want to do. So in this case, we are not doing any of that. We are just rounding it up to the closest whole number, that is 283, right? So with that, we can calculate all the other things that we need to calculate. So with this, when only annual data is available, so this production rate, this ratio of demand rate versus production rate, like I said, it can be any units. It doesn't just have to be daily. It can be weekly, monthly, or even annual, right? So if you're given annual production rates, you can use the annual production rates formula, right? Now, we can calculate other things too in this case. So we can calculate, for example, how long were we doing the production? So remember the production cycle time. So the production cycle time, if you remember, was, the formula for that was, T was Q over P. So we decided that Q was 283 and we know that P is 8. So 283 divided by 8 will be what? 283 divided by 8 will be 35.75, right? So that's 35.75. And that's your cycle time. So every 35.75 days, you will stop production and then you let demand go down to 0. Then you'll start again and 35.5 days of production and then continue, right? So that's the idea. But what is the cycle time, total cycle time, where you start with 0 inventory and you end with 0 inventory? Well, you can calculate that also, right? You don't just it doesn't just have to be production time. In that case, it is just the total number of, it can be based off the number of orders. So if you remember, the number of setups that you will have is D over Q, right? So D was 1,000 for us. So D was 1,000. And you divide by 283. So number of setups for us will be 3.53, right? So 3.53 is the number of setups. So if you're doing 3.53 setups in a year, how many days between each setup? So if you do 250 divided by 3.53, that'll give us 70.82, right? So 70.82 days for the whole cycle, right? And 35.75 days just for the production. So just to quickly talk about this. So you'll say that 35.75 days of production and the whole cycle starting from here to here was 75.75 73.83 or whatever number we got in the 70s. And that's the idea there. Start with zero inventory, end with zero inventory, start with zero, end with zero. Initially, you're doing production and demand at the same time, and then you're just reducing inventory because there's no production anymore. And that's the production order quantity model, which is just an extension of the economic order quantity model, right? I'm going to stop this here. So this was the production order quantity model. Now I will also post a video about the quantity discount model, which is the next model that we'll talk about, and I will see you in that one. All right, take care.